everyone, myself Henning Satwara. I hope you have enjoyed my last lecture, which is based on full wave rectifier, because today we are going to discuss about bridge wave rectifier. So let us start with bridge wave rectifier, or we can say bridge rectifier, with this chart. Here we can see this is the classification of rectifiers. Rectifiers are classified into two types. First one is half wave rectifier and second one is full wave rectifier. In full wave rectifier, it is divided into two types. Number one, full wave rectifier with center tap transformer, and another one is bridge rectifier. Because here this is the full wave rectifier, that means we will get full wave output. So this is known as full wave rectifier, as we discussed in our previous lectures. So here circuit diagram is little bit different. So let us discuss about full wave rectifier and with bridge rectifier. So let us start with its construction, or we can say circuit diagram. So here this is the circuit diagram of full bridge wave rectifier. Here we can see there are four different types of diodes are used, along with load resistor and step down transformer. Now in this circuit diagram we will enter input waveform, or we can say AC waveform from the input side, and we will get output from the RL, across the RL, that means load resistance. So here we are going to discuss about two different waveforms. First we considered positive half cycle, then next we going through negative half cycle. So let us discuss first positive half cycle. If we entered positive half cycle in the input side, what is our output? So here is the circuit diagram. This is the bridge rectifier for positive cycle. So if we enter here positive cycle, at that time only two diodes is working in forward bias, because two diodes is in the direction of flow of current, whereas two diodes D3 and D4 is the opposite direction of flow of current. So it works in reverse bias. And we have discussed earlier that if current flowing from anode to cathode, that means your equivalent circuit will be closed loop. That means it works in forward bias. If current flowing from cathode to anode, that means your diode work in open circuit. That means in reverse bias. So here we are going to discuss about the flow of current, and with this flow of current, your two diode at a time going to work in forward bias. That means closed switch. So let us discuss, if we entered current plus to minus, then your current flow from this direction and going through the direction of diode's symbol D1. So it becomes closed loop. Here you can see it becomes closed loop. Then it goes to the load resistance RL, and we have to find output voltage across this load resistance RL. Now it goes through this terminal, and now we can see it passing through the diode D2 in the direction of flow of current. So D2 works in forward bias and going through this negative polarity. So basically here current flowing from positive to negative. At this time we have to measure voltage across load resistance. And what will we get? Here we can see if we enter positive waveform, then across RL we will get positive waveform. That means similar as we entered in input. So our output will be positive half cycle, because current always flowing from upper to lower, plus to minus formation. So here D3 and D4 works in reverse bias. So let us discuss about its waveform. Here we can see negative half cycle. If we enter negative half cycle at the input side, then what happened? Always current flowing from plus to minus. So in this direction current is flowing. Now diode D3 direction of flow of current. So it becomes forward bias. So we can say it is equivalent to the closed circuit. So like this, and it passing through the load resistance RL, and across this load resistance we will get our output. Now current is passing through this terminal, and here we can say this is the junction where current is divided. If current flowing from D4 side, that means it becomes closed loop. If current flowing from D2 side, then it becomes open circuit because it works in reverse bias. That's the reason. So it will be open circuited D2 and D4 is closed loop, closed circuited. So current is flowing from plus to minus like this. So in this circuit diagram, for we can say negative half cycle, D1 and D2 becomes reverse biased because current flowing from cathode to anode. That's why it becomes reverse bias and it becomes open circuited, whereas D3 and D4 works in forward bias and it becomes closed circuited. So now we are going to discuss about output voltage. If we enter negative half cycle, but here we will measure our output across the load resistance RL. So current flowing from plus to minus, that means upper to lower side. This is the same manner as we discussed in positive half cycle. So that's why our output will be positive. So this will be positive. Here we can see this is the positive half cycle waveform. If we enter here positive waveform, then we will get positive waveform at the output side, 0 to pi. So this is the positive half cycle waveform. Now for negative half cycle waveform, if we enter negative portion pi to 2 pi, here this is the pi to 2 pi, we will get positive waveform because it is the same as the we discussed in positive half cycle. So current always flowing from plus to minus. So here we will get positive. Again, if we enter negative half cycle, then we will get positive at the output side. So this is the waveform for negative half cycle. Now let us discuss about final waveform. If we enter positive waveform and negative waveform both together, then output current will be like this. For positive, we will get positive. Negative, we will get positive as well. Here we can see, but its amplitude is lower than the voltage. Why? Because here I is equal to V by R. Now here I is equal to Vm by Rs plus twice Rf plus Rl. That means here Rs means reverse resistance, Rf that means forward resistance. Why here twice? Because at a time two diode work in forward bias. So twice Rf plus Rl, that means load resistance. That's why here we can see its amplitude is lower than the voltage. Now talking about voltage, output voltage, so we will get like this output voltage, positive, positive, and here we can see for first positive at that time diode D1 and D2 is on, whereas D3 and D4 is off. For second half cycle, D3 and D4 is on, whereas D1 and D2 is off. Similarly, we can see here. And for last half cycle, diode D3 and D4 is on, and D1 and D2 is off. So this is the overall output for the bridge rectifier. So that's all for today's lecture. Thank you.